Hello friends, I Dr. Rupali Indine and now today we want to see the soil chemistry part 4 from agriculture chemistry. Hope so you remember our last lecture. In last lecture we focuses on the pedologist described soils by characteristics of soil horizons and we also see the three characteristics of soil like soil color, soil texture and soil density. Now in today's lecture we see the remaining characteristics of the soil and see the fourth characteristics, that is soil structure. What is the soil structure? When soil particles aggregate, they form clumps of soil that are called beds, and most bed ranges from less than 1.5 to 15 centimeter in diameter, as well as their shape and arrangement of beds determine the soil structure. This ability of beds and soil particles to stick together and hold their shape is called consistence. The most soils contain two or more kinds of structure, and out of that some soils have no definite structure. In some such soils, the beds lack a definite shape or arrangement. Now guys, today we focuses on the soil structure, and in others there are some soils in which the particles do not get aggregate, that means they do not form clumps. And then we have to focus on the kinds of soil structure. First is the plate-like structure, second is prism-like structure, while third is block-like, and last type of soil structure is spheroidal. We want to see all these structures with their pictures. Now see, before going to that, firstly we focuses on the detailed classification of soil structure, and this soil structure is mainly or basically divided into 6 classes. Like as first one is the prism like, second one is the plate like, next one is spheroidal structure of soil, single grain, block like and massive. Out of these 6 classes, 3 classes are subdivided, like as prism-like soil structure is divided into 2 types or classified into 2 types, like columnar soil structure, and second one is the prismatic soil structure. While spheroidal soil structure is again classified into 2 types, granular, that means non-porous soil structure, and second class is the crumb, that is porous soil structure. Along with the spheroidal, block-like soil structure is also divided into 2 types. First one is the angular blocky and another is the subangular blocky. We have to see the pictures how they looks like. Now go for the next crump, that is spheroidal soil structure is divided into crump and granular, and they are looks like this. While plate-like soil structure looks like plates. Block-like structures of soil looks like as an angular blocky and subangular blocky, while prism-like have their distinct shape. Prismatic having prism-like structure, while columnar, that means they show the columns-like structure. Now these plate-like plates are thin horizontal plates that occur in any horizon. Guys, in last lecture we see the horizons or types of horizons, and there are 3 types of horizons we are already studied. Which are these 3 types? A horizon, B horizon and C horizons. Okay, if the units are thick, they are plates-like, while if the units are thin, they are called laminar. Plate structures are usually found in surface soil and lower subsoil. Prism-like beds are of two types, like prismatic aggregate having flat tops or showing the prism-like structure, while second one is the columnar aggregate is having rounded tops or simply looks like as an column. Okay, then go for the next. Block-like beds look like block with flats or curved sides. Large flat-sided block-like beds commonly occur in subsoil. We know what is the subsoil and what is the surface soil. Small rounded block-like beds make up most of the topsoil. They contain much organic matter and hold water and nutrients better than do the large beds. These spheroidal beds are also of two types. Which are these? Crumb structure, which has small aggregate, weakly held together and porous like breadcrumbs. While second one is the granular structure, which is similar to crumb structure except that aggregates are harder, less porous and individual soil particles are strongly held together. These are found in cultivated fields. That granular structure of soil we have to see in the cultivated fields. Now then we focus on our next point, importance of soil structure. Why we study the soil structure? Soil structure helps in determining the relationship that exists between soil water and plants. It controls the amount of water and air present in soil and also their circulation and movement. The presence of abundant nutrients in the soil is not sufficient to ensure proper crop growth and high yield unless that soil have an optimum air water nutrient relationship is maintained by producing proper soil structure. On the other hand, soil structure also depends on the cultural operations like ploughing and other operations that are carried out in the soil. Now then, after importance of soil structure, we have to focus on stability of soil structure. Now the breakdown is an important property for the maintenance of soil structure under field conditions. That means whatever the beds or clumps of soil form, they get breakdown, and it's an important property for maintaining the soil structure. Crumbs formation cannot remain stable. That means they are broken due to beating effect of rain, pulverizing effects of cultivation operations, flaking effects of rain, the pulverization effects of cultivation operation and the grinding effects of blowing wind. All these, due to all these effects, these clumps or pits are getting breakdown. In cultivated lands, the disintegration of crumbs is brought about by the shattering effect of air as the soil aggregates are wetted and by mechanical pulverization. That means we see the stability of soil structure, and stability of soil structure is maintained by the important property of crumbs which is breakdown. Now see or focus on next an important factor influencing the stability of soil structure is the type of ions countering the negative charge of the clays, and the principal charges among them being calcium 2 plus or magnesium 2 plus or aluminium 3 plus. Sodium plus, that is monovalent ion, provides relative weak bonding forces between particles. And soil having high concentration of sodium are often poorly aerated. Aeration is less in that soil where percentage or amount of Na plus is high. Why? Because of lack of charge and structure related pore spaces. Due to this, that soil is poorly aerated. The physical state of these soils can be improved if sodium plus is replaced by calcium 2 plus. Cementation is the another important factor in the stability, and the cheap cementation agents are lime, silica, etc. That means in this we see how we maintain the soil structure, or for maintaining the soil structure what we can do. Now see next point, stability of soil structure also depends on the organic matter present in it. See the next point, that is soil temperature. Soil temperature influences germination and initial growth of plants. During plant growth, the physiological processes of carbon assimilation and respiration are influenced by temperature. It also increases or influences the solubility of food nutrients and their availability. It also affects root growth, microbiological processes involved in the growth of plants. And we know microbiological activities varies directly as temperature. And by favoring the growth of different types of microorganisms at different temperature, soil temperature influences the type and amount of decomposition products. That means soil temperature is also necessary thing for the soil. The activity of microorganisms is lowered when the temperature is below 5 degrees Celsius and above 54 degrees Celsius. That means the optimum temperature for the activity of most microorganisms is in between or is in the range of 25 to 35 degrees Celsius. It also influences, that means temperature, influences various chemical reactions that takes place in the soil. And the rate of reaction varies directly with the temperature. Development of various diseases are also related to temperature. At low temperature, soil contains weakly parasitic fungi which will grow actively and very rapidly, killing the seedlings. And variation in soil temperature affects the absorption of soil water by the plant roots. That means soil or the activity or structure of soil is also depend on the soil temperature. Then we see the factors affecting the soil temperature. Which factors affected on soil temperature? See one by one. The temperature of soil is affected by number of factors like nature of soil, soil moisture, plant cover, topography, climate season, soil treatment, etc. Now see the first one, that is nature of soil. Factors responsible for variation in soil temperature are: the dark colored soil absorbs more heat than light colored soil, and the drop in soil temperature due to change in color is more pronounced during the day than at night, and black or dark color soil which contain humus do not absorb much heat. That means organic matter is an important factor for soil. Now see the second factor. As the specific heat of mineral matter and organic matter present in soil differ in the capacity of the soil to absorb heat, also varies with the relative proportion of mineral and organic matter. Soil texture affects soil temperature by controlling the pore space or the amount of air in the soil. Soils having good structural conditions warm up more rapidly than when the structure is impaired. Difference in heat conductivity. Now, after seeing the soil nature of soil, we focus on the second factor which affect on the soil temperature, that is soil moisture. We know soil always contains some moisture, and moist soil have high specific heat than dry soil because the specific heat of water is high. The greater the moisture content, the greater is the heat required to raise the soil to a particular temperature. The cooling effect of moisture is greater during the day than at night. Now see the third one, plant cover. It acts as an insulating material and reduces temperature variations. Soils carrying a dense plant cover are cooler in summer and warmer in winter as compared to unprotected soils. Next factor is the soil topography. The topography of the land, more particularly the ground slope, also affects the temperature of soil because the angle at which sun radiations falls on the earth greatly affect the amount of radiations received per unit area, and the radiations received per unit areas varies inversely as the angle. Now here we have to focus on factors affecting soil temperature. Now go for the next factor, that is the climate. The temperature of soil in region where rainfall is high is lower than where it is less. Sea coast soil have lower temperature than land soil, as well as soil in temperate and cool Arctic regions are cooler than in tropical and semi-tropical regions. And last point is the season. Soil temperature varies with different seasons of the year. Here we see the factors affecting on soil temperature. Now go for the next characteristic of the soil, that is porosity of soil. Its percentage pore space. It is the percentage pore space by volume in soil is called the porosity. It can be calculated from its absolute and apparent specific gravity by following the formula percentage pore space is equals to 100 minus apparent specific gravity divided by absolute specific gravity multiplied by 100. By using this formula, we find out the percent pore space, that is the porosity. It gives an idea of the total pore space present in soil or the percentage of soil volume that is not occupied by soil particles. Porosity of soil decreases in the particle size, in pore space and depth of soil. That means as the depth of soil increases, porosity of soil decreases. Now see, the pore spaces are responsible for better plant growth because that pore spaces contain enough amount of air and moisture. The percentage of solids in soil can be calculated by comparing bulk density and particle density multiplied by 100. See the formula for that. Percentage of solids is equals to bulk density divided by particle density multiplied by 100. It is, or this formula is used to find out percent solids. Now go for the thank you slide. Thank you very much. We will stop here and in next lecture we continue our topic. Thank you.